The Mysterious Bloodfalls of Antarctica, Part 2. What if I told you that everything we thought we knew about bloodfalls was only scratching the surface? Remember that eerie red waterfall in Antarctica we explored in Part 1, the one that had been staining the Taylor Glacier for more than a century? The truth turns out to be even stranger and more inspiring than the rumors.
This is a tricky little feature. It doesn't always flow when you'd like it to, I guess. So it's one of those challenging mysteries to study, and it always keeps me guessing.
Over a century ago, in 1911, Australian geologist Griffith Taylor first spotted bloodfalls. At the time, he thought the color came from algae. Today, scientists know it is iron-rich brine welling up from beneath the ice. What lies beneath Taylor Glacier is a window into a world sealed away for more than 1 million years. Not in the sense of alien invaders or sci-fi monsters. Instead, it is an ancient ecosystem of microbes that thrive in total darkness, cut off from the sun and air long before humans walked the earth. Buckle up, because in the next 10 minutes, we are diving into discoveries so extraordinary that they have reshaped how we think about life on this planet and where it might exist beyond Earth. Last time, we explained how bloodfalls gets its dramatic red color from iron oxide. We also covered how salty brine can stay liquid even below freezing, flowing through fractures in the glacier. Now, here is where the science gets incredible. In 2015, a team led by Dr. Joe McCuckey from the University of Tennessee used airborne electromagnetic imaging, essentially a helicopter-mounted scanner, to peer beneath the glacier. It worked like an MRI machine for ice. What they found was stunning. The waterfall we see is only one tiny outlet. The outflow is part of a much larger hidden brine system that stretches at least 5 to 6 kilometers inland. In other words, bloodfalls is not a standalone oddity. It is the visible leak of a vast ancient network, a subglacial aquifer that has likely been sealed beneath Taylor Glacier for around 1.5 million years. So, how does it still flow? The answer is not 30 times sea level pressure, as some have claimed. The real mechanism is better. 400 meters of solid ice pressed down on the brine. This immense weight creates enough hydraulic pressure to force salty water upward through cracks and fractures. Scientists describe it as a natural pressure relief valve, where bursts of liquid escape episodically to the surface. Here is the twist. The brine is so salty, about 3 times saltier than seawater, that it does not freeze even at -7 degrees Celsius. The chemistry, combined with the pressure, keeps its liquid under conditions that most of us would call impossible. What we are looking at is a dynamic living hydraulical system pulsing under the ice and occasionally revealing itself through that haunting red glow. The time capsule ecosystem. Here is where things get truly mind-blowing. When scientists drilled into the glacier and retrieved samples from the brine, they did not just find water, they found life. Living microbes, not dormant, not fossilized, active organisms thriving in total darkness without sunlight or oxygen for hundreds of thousands to over 1 million years. Genetic analysis revealed that these organisms have been evolving in isolation since long before humans discovered fire. While our ancestors have been learning to spark flames, these microbes were perfecting strategies for survival in one of the harshest environments on Earth. Their survival trick is called chemosynthesis. Instead of using sunlight, they harvest energy from chemical reactions involving iron and sulfur dissolved in the brine. Microbes related to sulfur oxidizers like Theomicrospira metabolize sulfur compounds, while closer relatives of Merino use iron. Together, they form a self-sustaining community in a world without light or oxygen. As Dr. John Priescu of Montana State University once said after decades of Antarctic research, Blood Falls is evolution's extreme experiment. This is not a static museum piece. The ecosystem is alive, dynamic, and still teaching us how life adapts to conditions that would kill almost everything else we know. The real biotech promise. In the past, you may have heard wild claims about miracle enzymes eating plastic, proteins, preserving human organs for decades, or billion-dollar pharmaceutical deals. Let us set the record straight. Those claims are fiction. The truth is still remarkable. The microbes of Blood Falls represent a treasure trove for science, not because miracle cures already exist, but because extremophiles are the ultimate test case for biotechnology. Their enzymes, known as extremozymes, are built to function under extreme cold, high salinity, or oxygen-free conditions. That makes them incredibly valuable. Imagine enzymes that can break down industrial waste and toxic brines, catalysts that keep working in freezing conditions where normal biology fails, or proteins stable enough to help produce food, fuel, and medicines. Research on extremophiles around the world has already yielded antibacterial compounds, robust enzymes for detergents, and potential biofuels. The microbes at Blood Falls expand this frontier, showing us new ways life can survive under extremes. The real value is not a flashy $2 billion market figure. The real value is knowledge. It is the chance to learn how life stretches its limits and how those lessons might inspire breakthroughs in science and technology. Blood Falls is not a gold mine. It is a natural laboratory that has been running an experiment for 1.5 million years. Blood Falls as a space analog. Now, let us zoom out. Blood Falls is not just about Antarctica. It is about Mars, Europa, and Enceladus. For years, scientists have recognized Blood Falls as a Mars analog site. The extreme cold, the salty liquid water, the absence of sunlight, and the isolation from the atmosphere make it one of the best early parallels for life under Martian ice. If microbes can survive beneath Taylor Glacier, perhaps life could also exist in hidden aquifers on Mars or beneath the icy crust of Europa. Blood Falls is also where real instruments are tested. The IceMol probe, developed in Germany, can melt and drill its way through ice while collecting clean samples without contamination. NASA's Trident drill, designed for lunar missions, uses similar concepts. These technologies are being refined in Antarctica so that one day they can search for life beneath alien ice. No acronyms invented for drama, no secret announcements, just real groundbreaking science. The human side. What sensational stories often leave out is the human side. Studying Blood Falls is not about hidden conspiracies. It is about endurance. Scientists travel halfway around the planet, set up camps in brutal weather, and keep everything sterile so modern microbes do not contaminate what they study. Drilling through ice without contamination is a massive challenge. It is the same problem space agencies face when designing missions to Europa and Enceladus. How do you search for life without carrying life with you? Blood Falls teaches us about biology, but it also teaches us how to do science cleanly, responsibly, and at the very limits of human ability. The climate connection. Blood Falls also tells a story about Earth's past and its future. The trapped brines hold gases and isotopes that act like a climate time machine. They preserve records of how Antarctica has changed over the last 1.5 million years. During the Pliocene, when CO2 levels were similar to today, each of East Antarctica may have been ice-free. By studying these sealed aquifers, scientists can reconstruct how the ice sheet responded and predict how it might respond again. And if this blew your mind, wait until you hear about Lake Vostok, Antarctica's largest subglacial lake that has been sealed for 20 million years. Lake Vostok, the ultimate hidden world. Picture this. Buried beneath 2.5 miles of solid Antarctic ice lies a body of water roughly the size of Lake Ontario. Not frozen, not dormant, liquid water that has been cut off from the outside world for millions of years. This is Lake Vostok, and it makes bloodfalls look like a puddle. In 1996, Russian scientists using space-based radar made an announcement that shook the scientific world. They had found not just one subglacial lake, but evidence of a hidden aquifer system. Lake Vostok was the crown jewel, one of over 400 subglacial lakes scattered across Antarctica like a secret underground archipelago. But here's where it gets truly extraordinary. The Russians had been drilling at Vostok Station since the 1970s, extracting ice cores for climate research. For nearly 4 decades, they bored deeper and deeper through Antarctic ice, creating one of the most ambitious drilling projects in human history. Then, in 2012, after 37 years of drilling, they did something no human had ever done before. They broke through. At 3,769.3 meters deep, their drill bit punctured the ice ceiling of Lake Vostok. For the first time in millions of years, this ancient world was no longer sealed. The alien world beneath our feet. What they found challenged everything we thought we knew about life's limits. When Russian scientist Sergei Balot analyzed water samples, he discovered genetic sequences that appeared to be from unknown microbes. It was an unprecedented claim, unidentified and unclassified life. Not 1 or 2 species, hundreds. Initial genetic analysis revealed a reverse range of microbial sequences, but the scientific community was skeptical. The researchers had used kerosene and freon to keep the borehole from freezing, and many argued the findings were simply contamination from the drilling process. Think about this timeline. The ice above the lake had been in place for 15 million years. While these microbes may not have been completely isolated for that long, they were still living in a bizarre, extreme environment, evolving along their own separate path. They created their own world, their own rules, their own biology. The pressure cooker of evolution. The conditions in Lake Vostok are unlike anywhere else on Earth. The lake sits under pressure 360 times greater than our atmosphere. That's like being crushed under a column of water 2.2 miles high. The water temperature hovers around -3 degrees Celsius, liquid only because of the immense pressure and dissolved gases. In complete darkness, in water so oxygen poor it should be sterile, cut off from any energy source except what they can create themselves. Yet, life doesn't just survive there, it thrives. Dr. John Priscu, who has spent decades studying Antarctic extremophiles, calls it a perfect natural laboratory for understanding life's boundaries. These organisms have had millions of years to perfect survival strategies we're only beginning to understand. The Europa connection. But here's why Lake Vostok matters beyond Earth. Jupiter's moon Europa has an ocean beneath its icy crust that's remarkably similar to Lake Vostok. High pressure, complete darkness, isolated for millions of years. If life can evolve and thrive in Lake Vostok's extreme conditions, then Europa's hidden ocean suddenly looks a lot more promising. NASA's Europa Clipper mission, which launched in late 2024, is carrying instruments tested on concepts learned from Lake Vostok research. The drilling techniques, the contamination protocols, the sample analysis methods, they're all being refined in Antarctica so we can one day search for life in alien oceans. Enceladus, Saturn's icy moon, presents an even closer parallel. Its subsurface ocean occasionally erupts through geysers in its south pole. Natural versions of what we see at blood falls, but on a moon 900 million miles away. Lake Vostok isn't just teaching us about life on Earth, it's showing us what to look for when we search for life beyond Earth. The controversy and the caution. Not everyone celebrated the Lake Vostok breakthrough. The moment that drill bit punctured the lake's ceiling, it potentially contaminated a pristine ecosystem that had remained untouched for millions of years. Some scientists argue we've already irreversibly altered one of Earth's most unique environments. The Russian team's use of kerosene and freon to prevent their borehole from freezing raised alarm bells. These chemicals are now mixed with the lake's ancient waters, and future samples will forever carry traces of human contamination. It's the same ethical dilemma space agencies face with Europa and Enceladus. How do you study life without destroying what makes it unique? The Lake Vostok controversy has shaped every subsequent Antarctic drilling project. Scientists now spend years developing sterile drilling techniques and contamination protocols, because what we've learned from this one mistake could be the difference between discovering life on other worlds and accidentally destroying it. The unfinished story. Today, Lake Vostok remains largely unexplored. The lake itself is considered inaccessible due to contamination concerns and international environmental treaties. Most of what we know comes from ice cores drills from the frozen lake surface and remote sensing. But the implications are staggering. In early 2024, Russia celebrated the completion of a new modern research facility at Vostok Station, a project that had been years in the making. The international scientific community emphasizes that any future research must prioritize environmental protection over sensational discoveries. The truth is, Lake Vostok has already changed how we think about life in the universe. The debate over those initial samples is rewriting microbiology textbooks. The survival strategies perfected under miles of ice are inspiring new biotechnology research. But the lake's greatest discovery might still be waiting beneath that ice ceiling, in the dark waters where evolution took a completely different path. Lake Vostok reminds us that our planet still holds secrets we're only beginning to understand. And if life can exist here, isolated, pressurized, and forgotten for millions of years, then maybe, just maybe, we're not alone in this universe after all. So, where does that leave us? Blood Falls is not a conspiracy. It is not a billion-dollar secret. It is not alien life hiding on Earth. It is something better. It is a reminder that science thrives on curiosity, persistence, and collaboration. The most astonishing discoveries are not hidden. They are waiting in the open for someone determined enough to go find them. The microbes beneath Taylor Glacier are not rewriting biology overnight, but they are reshaping our understanding of life's possibilities. They remind us that even in the darkest, coldest, most inhospitable places, life finds a way. The real mystery is not what is being kept from us. The real mystery is not what is being kept from us. The real mystery is, how can life exist in a place so cut off, so cold, and so extreme? Answering that question may one day help us answer an even bigger one. If life can exist here, where else might it exist?